Hello again, everyone. Welcome to our discussion of the binomial theorem. A lot of equations or expressions in mathematics can be written as a binomial. Binomial is any expression with two terms, and then a lot of times we have to raise the binomial to some power, as we will see in this section. So that's a binomial. Right there, a plus b to the fifth power, that's a binomial raised to the fifth power. We have a lot of expressions like this in mathematics. A lot of relationships or data can be summed up in expressions like that, a binomial raised to some power. Now, in this section, we will talk about two different ways of finding the expansion of a binomial. In other words, we're talking about not 3 terms or 4 terms. How do we expand 2 terms that are raised to some power? How do we find individual terms from that expansion is the main topic of this section. Then the easy part is finding the individual terms. I mean the individual, a to the fifth, a to the fourth, a to the fourth times b, a cubed times b squared, a squared times b cubed, a times b to the fourth, and b and plus b to the fifth. Those terms are easy to find. Notice how the pattern, right? If we have a binomial to the fifth term, if we have that, then the way we expand it, the first term raised to the fifth power, to the power on the outside. Look at the first and the last terms. Okay, the first and the last terms. The first term is the first term in the binomial raised to the fifth power. The last term is the second term in the binomial raised to the power on the outside, which is 5. So that's easy, right? Then look at the second term. The second term, this power of the first term is reduced by 1, and then we bring the second term with the same power that was reduced here associated with the second term in the binomial. The result is a combination of 2 terms for which the powers add up to that power on the outside, and they should. So a to the fifth, okay, the 5 is equal to that. That's easy to see. The second term gets a to the fourth, so that power is reduced by 1, times the second term with a power such that if you add that power to 4, you get 5 again. 1 plus 4, 5. Great. So let's see if that pattern exists throughout this expansion. It does. So the next term, or the third term, has its power reduced by 1 from 4 to 3, and then the power for b, or the second term in the binomial, is increased by 1. The result is a combination of terms for which if you add the powers, you get 5. How about that one? Again, the same thing. Reduce that power by 1, becomes a squared. Increase the power of the second term in the binomial, that is, by 1, you get b cubed. 3 plus 2, again 5. This one, again, you reduce the power 2 by 1, it becomes a to the first power, or a, times b, and increase the power 3 by 1, b to the fourth power. So 4 plus 1, again 5. And of course, the last term has a power equal to the power on the outside. So that part is easy. That always is the same pattern. What's not so easy are these coefficients, because we just found the terms but not the coefficients. The question marks you see are the coefficients of these terms. In this section, we will talk about two very different ways of finding the question marks, which are the coefficients of each term in the expansion of a binomial. Okay? One of those methods is the Pascal's triangle. In a second, we will look at that. And the other one is called the binomial theorem, or we use the binomial coefficient to find all of those question marks. Okay? Before we do that, before we look at the Pascal's triangle, because the question comes up in the classroom whenever I talked about this topic, so let me mention it here. Everything you see here is if we had a plus b. What about a minus b to the fifth power? Would this apply? Yes, but you got to be careful. How? This is how. If we have a minus b to fifth power, once again we have the question marks. So we're going to look at that later, or in a couple of minutes. But how does that, going from plus to negative, affect the outcome of each term? Well, for the first a to the fifth, it's still going to be a to the fifth. And the coefficient we will look at, right? So let me put the question mark for the coefficient there. Then plus, once again, the coefficient stands or stays. We will look at that. Then the second term, we got to be careful. Why? Because just like that, a is going to lose 1 from its power, so it's going to be a to the fourth. But b to first power, now it's going to be, so a to the fourth is not going to be times b, it's going to be times minus b. Because of this minus, it's going to be there. And the power is 1, so this minus, 1 is odd, right? So this minus raised to first power is not going to go away because 1 is odd. So this minus is going to change this plus to a negative. How about the third term? Well, we're going to have the question mark, which we will look at in a minute. Then a cubed will be a cubed again. Then that b squared, instead of b squared, it's going to be minus b squared. So do you see what effect does it have if we go from plus to minus? The red, what you see in red ink, is the effect. Okay, we need to keep track of that. And then for the fourth term, we have plus the question mark again. A squared is a squared, but in b cubed, it'll be minus b cubed. Okay, then we continue, plus the question mark. Then a is a. We got to be careful about the b. It's going to be minus b to the fourth. Then plus the question mark. And b, instead of b to the fifth, it'll be minus b. I should have written that in red, sorry. Minus b to the fifth power. Okay? That's the effect of changing from plus to minus. We got to be careful about that second term because it's going to be a negative associated with it as we raise it to different powers, which whenever we have an even power, it's going to cancel this negative, right? For that term, and when minus b to the fourth power, this is going to stay positive because the even power will cancel that. But for odd powers 1, 3, and 5, that minus is going to be preserved, and it's going to change that plus to negative, this plus to negative, and this plus to negative. Okay. Okay, so now that we've talked about that, and I should highlight the question marks, but it's gonna make the ink smear like that. So the question mark. So the rest of this lesson will look at how to get that number for the question mark. Okay, that's where the Pascal triangles comes in as one method, and after that we will look at the binomial theorem. So the Pascal's theorem starts by these ones on the outside. So as I'm showing you the completed triangle, and this triangle can go as far as it needs to, but in this figure that I'm showing you, it's gone up to a plus b to 8th power. Okay, I could have continued this to a plus b to 9th power, a plus b to 10th power, however many powers or other increasing powers, it will work. Okay, but let's see, how do we get this triangle? So this triangle builds from these ones you see along the perimeter of this triangle, set up first before anything. So let me do that. So 1, and then 1, 1 on the outside, another 1, 1. I'm putting the ones on the outside of each row, like that, like this, like that, like that, like that, like that. Let me stop there, right? But every one you add here, you got to add another one there. So that's where it starts. First with the perimeter, or the ones along the perimeter of this triangle. Then, this one, the top of this triangle or pyramid is associated with a binomial of this type, a plus b to 0 power. Okay? That is going to be the coefficient. That is going to, this row is going to determine the coefficient of any binomial to 0 power. Okay? Then, for the second row, we're going to add these two. So 1, and if you have for the second row, if you have a plus b to power 1, the coefficients are going to be just whatever a and whatever b is times 1. So that the 0 and the 1 are not going to make any difference. It's just the same two terms, basically. If the power on the outside here is 1, you basically are going to have the same two terms, a and b. Okay? Or a minus b, whichever the case. Now, for this row, you add these two. This one, 1 plus 1, you end up with 2 for the same row. So these are the coefficients of the expansion of this binomial, a plus b to 2nd power. So notice we begin with 0 power at the top of this triangle, and then we add 1 to it as we move along. So these are the coefficients, right? So what about the other coefficients? So 3, 4, 5. What I've done goes up to 5. Let me add another 1 to it because we have 6 terms here, so we're going to need another added to that. Okay, so what about these coefficients? Well, add the 1 and 2, what do you get? 3. 1 plus 2, 3. On this side, 2 plus 1, the same thing, 3. So these become the coefficients of the expansion of a plus b to 3rd power. One thing I want you to notice the number of terms the number of terms is always one more than the power. So if the power of the binomial is 0, how many terms you have? 1. And the coefficient of it is just 1. If you have if you have power 1, how many terms do you have? 2. Right? So you have 2 terms if the power is 1. If you have power 2, how many terms do you have? 1, 2, 3. So notice the number of terms in the expansion of a binomial, or 2 terms, is always 1 more than the power. So in this row, the power is 3. How many terms do we have in the expansion? 1, 2, 3, 4, with these coefficients. Okay? So again, we have 4 terms, 1 more than the power. So that means you have whatever you have the power, you can add 1 to it, and you know how many terms you're going to have in the expansion before you even begin the expansion. That's a very, very useful tool, right? So suppose if this power is 20, then how many terms we would have in the expansion? 21 terms. If it's 50, how many terms? 51 terms, and so on and so forth, right? Okay, so for the next row, the coefficients are obtained by 1 plus 3, so 4, then add 3 and 3, we get 6, and then 3 plus 1, again we get 4, which we had on this side. Okay, so this row are the coefficients of the binomial raised to the 4th power. How many terms do we have? 1, 2, 3, 4, 5. Again, 1 more than that power. How about the next row? Well, 1 plus 4 is 5. Okay? 4 plus 6, 10. Do you know what we're doing? We're finding those coefficients that I highlighted in yellow. You see the question marks? We don't have those. This is the way to find them. When I get here, we'll know the coefficients for that expression. We'll know all of those question marks, what those numbers are. Okay? 6 plus 4, again 10. That's this row. And then 4 plus 1. I don't want to put pluses because it gets crowded, this drawing. So 4 plus 1, 5. So these are the coefficients of the expansion of this binomial, a plus b to 5th power. Okay, how many terms do we have? 1, 2, 3, 4, 5, 6. 1 more term than that power. 5 plus 1, 6. Okay, as it turns out, 1, 2, 3, 4, 5. As it turns out, we don't need these. We don't need another row. We got it. So what are these numbers representing? These numbers representing the coefficients that the question marks, which I've highlighted in yellow, for that first binomial, not the bottom, which I added because of the minus. Okay, so let's write it out then, the full expression, because here we don't have the full expression. The question marks are missing, right? So we can write, let me move this up a little bit, like that. Okay, so a plus b to the 5th power, which is that, is equal to the first number, the first coefficient, question mark here, is going to be 1. 1 times a to the 5th power, which is a to the 5th power, right? plus, what's the next coefficient? Plus, that is the second number, 5. So 5 times a to the fourth b. Do you see what's happening? You're not here, so I can't hear your questions if you have any, but I hope it's clear what's going on. So we stopped when we got to the binomial to the power that we have, right? A plus b to the fifth power. Now those are the coefficients which are the question as shown as question marks here. Okay, so the third term is that one, a cubed b squared, right? Plus a cubed b squared. What about the coefficient, the question mark? That's going to be the third number, 10. Okay, so this Pascal's triangle is giving us the coefficients. Okay, plus the fourth term is a squared b cubed, right? So what is the coefficient of that? The fourth term, 1, 2, 3, 4. 1, 2, 3, 4. It's 10. So plus, the next term is ab to the fourth power. ab to the fourth power. What about the coefficient? What's the coefficient? 5. Plus 1 times b to the fifth power, which is b to the fifth power. So we were able to, and this is 1, so we were able to get these coefficients, and that's a 1, from the Pascal's triangle. 5, 10, 10, 5, and 1, right? 1, which are coming from these. All right? I hope you followed everything that happened here. So it's important for you to know what is the purpose of the Pascal's triangle. The Pascal's triangle gives us the coefficients of the expansion of a binomial. Okay, that's what it's doing. So this, what I've shown, goes up to a plus b to the 8th power. So you can see the coefficients for an expansion, a binomial expansion that has power 8. Okay, so this is what I was saying earlier, that the number of terms in the expansion is always n plus 1. N is the power. So n, this n is the power. So n plus 1. So if you have 8 as power, then how many terms you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what that is saying. If the power is 7, we must have 8 terms. Do we? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. We do. If the power is 6, we must have 7 terms. Do we? 1, 2, 3, 4, 5, 6, 7. Okay? That's that. So here, this is what you see here is what I ended up with here as I was explaining the Pascal's triangle. So this is the same result. Okay? So the Pascal's triangle identified the coefficients. This is, you don't see it because that's 1, right? 1 times a to the 5th. And that one, and that one, and that one, and that one, which is also 1. So all the highlighted quantities are determined by the Pascal's triangle. That's one of the methods. We have another method that we will discuss. It's the binomial. It's called the binomial theorem. Okay, well, that's a very different method than this. But imagine in an age where this method was invented, I believe, more than 400 years ago. So 400 years ago, if mathematicians wanted to find the expansion of a binomial, this method, without a technology, was extremely important, right? So, okay, so here I have an example for us to work through and find the coefficients using the Pascal's triangle. Okay, so we want to use that to expand this binomial. I'm strongly encouraging you to pause the video at this point, write down the solution of your own creation, of your own product, very, very important in your learning this topic, then unpause the video and look at my solution. Okay? All right, so I'm assuming you've done that, and now you have your own solution in front of you, which is great. So we will begin first with the first term raised to the full power on the outside. So we have 1 over x to the 4th power. This is, I have to be careful because that is minus, right? That's important in the next term. By the way, how many terms are we going to have in the expansion? How many? If you said 5, excellent, right? You notice this power plus 1, 4 plus 1, we're going to have 5 terms. Okay, so let's find each one. The next one will be plus 1 over x, reduce this power by 1, multiply it by minus square root of x to a power that when you add, you should get that 4. So we leave it alone, right? This is already 1. We're going to leave it alone. Plus 1 over x, of course, the question marks, right? The coefficients, we're going to need those coefficients later. So I'm going to put question marks for now. 1 over x time to what power? Reduce the power by 1, so 2, and then times minus square root of x to 2nd power, right? Once again, 2 plus 2 is 4, and that's what we like. So 1, 2, 3. We determine we have 5 terms, right? So we have 2 more terms to obtain. Okay, so 1 over x to 1st power, reduce this power by 1. I'm not going to write it because it's just 1. Times minus square root of x to 3rd power, right? 3 plus 1 is 4. And the last term, 1, 2, 3, 4, 5th term is going to be the last term. And that's going to be minus square root of x to 4th power. Okay? So, we look at the Pascal's triangle. We can look at the one that I have on the front page, right? For a binomial to 4th power, the binomial to 4th power, these are the coefficients. 1, 4, 6, 4, 1. Right? That's the same thing I got here when I did it here, right here. 1, 1, 4, 6, 4, 1. So let's put those coefficients with this right there. I'm going to cover the other ones. So you can see the binomial to 4th power has these coefficients. So these question marks are determined by these numbers. Okay, by these numbers. That one, that one, that one, that one, that one, and that's it. Okay, so let's plug them in. We have just 1. I'm not going to write it. So this will be just 1 over x to 4th power. Let me move this over like that. Okay. 1 over x to 4th power is 1 over x to 4th power. Plus this question mark, that's the 2nd term, right? So that's going to be 4. Plus 4, and this is going to be 1 over x cubed times minus square root of x. So I need to take into account that. So let me make this correction. This, because I'm simplifying each term now. So this minus is going to make this plus minus. So this is minus 4, which that 4 is coming from that, Pascal's triangle, that coefficient, times square root of x divided by x cubed. Right? We're simplifying as we're going along. Next one. Is it going to be plus or is it going to change? It's going to stay positive because minus squared, it's going to drop out. It's going to be positive because this is an even power. So we're going to have square root of x minus square root of x squared. It's going to be positive x. Positive x times, I don't want to skip this step, so let me simplify in a steps. So then the coefficient of the third term comes from the third number in the Pascal's triangle. So it's going to be plus 6. Then this is going to be x times 1 over x squared. So 1 over x squared times x, and I'll simplify in the next step. I prefer to do that rather than combine several steps in one step. Okay? Or rather than combining 2 steps in one. Okay, so the fourth term, right? 1, 2, 3, fourth term, what coefficient will it have? 1, 2, 3, 4. It's going to be 4. Is it going to be positive or is it going to be negative? It's going to be negative because this negative is being raised to an odd power, so this is going to change to negative. So minus and 4, right? Minus 4 square root of x cubed. So we accounted for the negative, right? So square root of x cubed, it's going to be x times square root of, let's see, so we're going to have, so this is going to be, let's write it for now, square root of x cubed over x, right? And then the last one, what coefficient will that have, the fifth term? 1. So that's just 1. It's neutral. Minus square root of x to fourth power. This minus is going to get canceled. It's going to be positive because of the even power. Square root of x to the fourth is going to be x squared. So we're going to have plus x squared. Okay, so let's simplify this a little more. The first term is okay. So let's write it down, 1 over x to the fourth. And this one, we can combine these. We end up with a negative power, and then we're going to have to rewrite it like that. So let's do that. But I will do it because I don't have enough space here. I'm going to do it on a different sheet of paper, right? If it's okay with you. So let's simplify this so all the x's are combined. What are we going to get? We're going to get, in the numerator, we have 1/2, right? Minus, if you move this, it'll be minus 3. So combining these, we're going to get x2 minus, this would be 2.5 or minus 5 over 2, and then 1 over x2, 5 over 2 power, or, so we now have positive, and then, so this will be, rewrite this in radical form, so we have x2 fifth power, square root of the fifth power, and simplifying that a little more, we're going to have 1 over a square root of x to the fourth power times x, right? Like that. And that is equal to, I'm just simplifying that, 1 over square root of, so this will be square root of x to the fourth, right? So we have x squared times x. I just rewrote x to the fourth like that. So this x squared can come out. So we'll have 1 over x squared, and it'll lose that power, and times square root of x. Okay? We can rewrite it like that if we want to. I'm having a second thought about that, because if we simplify it in this form, then this is going to have a radical expression in the denominator, and I don't want that. Okay? So let's leave our answers the way they are now, because the radical expressions are all in the numerator. I prefer that. So we're going to leave it like that. So minus 4 square root of x over x cubed plus this x, and one of this x will go away. We end up with plus 6 over x, right? One of that with one of with one of this. And then here we will have so we'll have minus 4 because of that x to the square root of x cubed. We will have x times, so that'll be x squared times x, and x squared can come out and become x, and we have that. Okay, that's just that simplified. Okay, so how did I do it? If you have questions on that, let me explain it here. So that square root of x cubed so square root of x cubed is equal to square root of x cubed, like that. So this power can come inside, and that is equal to x squared times x, right? That's x cubed. This x squared has power equal to the index, and it's being multiplied, not added or subtracted, to the other x. So we can bring it out. In the process, it'll lose the power with the radical, which is equal to the index. So we have x, that's this x squared come out, having come out, it becomes x times square root of x. And that's what you see here. X square root of x times negative 4, which is that. And divided by, let's see, where are we here? 1, 2, 3, 4. That one. So over x. So it looks like I can cancel even that, this and that, and then plus x squared. X squared. So let's, because I have enough room, let's simplify this with that, with the x's dropping out. So we have 1 over x to the 4th power, that's that, minus 4 square root of x over x cubed plus 6 over x minus 4 square root of x over 1, or minus that, just over 1, right? This x and that x cancel out, plus x squared. So that 1 we can ignore this 1. Okay, so that's the final simplified form. Again, we could combine these x terms in this one, but if we do, we're going to end up with a radical form in the denominator, either that or a negative power. So I'd rather have my radical expression in the numerator. So this is a better answer than if we combine these two x terms in the numerator and the denominator. Okay, so that's the application of the Pascal's triangle, which is mainly finding these coefficients for these binomial expansions. Okay, so now the second method. Pascal's triangle is not the only way we can find those coefficients. Another way is using the binomial theorem. So before we apply or talk about binomial theorem, let's make sure that we know what a factorial is. Factorial is a mathematical operation that was defined by a bunch of earlier mathematicians. So is there a natural way of demonstrating it? No. It's just an agreement. between mathematicians. So people ask me, well, why 0 factorial is 1 or 1 factorial is 1? And that exclamation symbol is the factorial. Okay, so I say to them, there is no reason other than this was determined as an agreement between mathematicians as a factorial, as that operation. So what is a 2 factorial? So we cannot divide by 0, but can we divide by 0 factorial? Yes, because 0 factorial is 1, not 0. Okay, 0 factorial is 1. So it's perfectly okay to divide by 0 factorial. 0 factorial and 1 factorial, both of them equal 1. The 2 factorial is calculated in this way. 2 times 1, 2. 3 factorial is 3 times 2 times 1, 6. 4 factorial is 4 times 3 times 2 times 1, 24. 5 factorial is 5 times 4 times 3 times 2 times 1, and so on and so forth. So for 8 factorial, you would do the same thing. So for 8 factorial, we'd say 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whatever that number. It's going to be a large number, right? 10 factorial is the same thing. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and then we'll calculate it. They are very large numbers. Can we calculate it using a calculator? Absolutely. On a calculator, in this one that I'm using, TI-30X2S, the PRB button, that stands for probability, or PRB. See that? When I hit it, it tells me NPR. In this course, we don't deal with that. NCR, we will deal with that in this course. That's actually the binomial theorem, or the binomial coefficient. We can use that button to calculate it. And the last one, do you see the last one? The exclamation mark. It's barely visible on the screen. It's so small. So if I use my arrow, I can scroll under it. But let me go back because I didn't enter a number. So I entered 8 factorial and 10 factorial. So let's see what numbers they are. So 8, then I'm going to hit the PRB button. I'm going to scroll under it to the factorial symbol, and I'm going to hit enter. It tells me it's going to calculate 8 factorial for us, and I hit the enter again, and there's that number, 40,320. That's if you multiply the numbers like that, 8 times 7 times 6, all the way to 1. Okay? The 10 factorial, let's calculate that. Right? This one. So we have 10, let's enter that, and then I'm going to go to PRB. I'm going to scroll over to that exclamation symbol, hit the enter. It's going to tell me it's going to calculate it. It's going to calculate 10 factorial if I hit the enter button again, and let me do that. There is that. Very, very large number, right? So factorial in general, it's rapidly growing operation of numbers, and even with the bigger calculator that I have, for example, I cannot calculate 100 factorial. I mean, let me try it here. Because the number is so large, the chip in this small calculator cannot handle it. So I get an error message. So 100, and then factorial, 100 factorial. So it gives me an overflow error. So it's telling me it's too big. The chip in this calculator, and even in my bigger calculator, the TI-83 or TI-84, is not powerful enough to calculate 100 factorial. On the other hand, it's probably not that surprising that the chips inside your cell phones are far more powerful. And if you use the calculator in your cell phone and calculate 100 factorial, you should be able to get that number. It's a very, very large number. But with your cell phone, you can calculate it, but not with the chips, with the computer chips that are in these regular calculators. Okay, so that's factorial. So now that we know how to calculate factorial, the binomial coefficient can be calculated using that. So what are n and r? N, as you know, that's the highest power of the binomial. So whatever the power is on the outside, 4, 5, 6, 7, 8. And r is the term that you're calculating r begins the incrementation with 0. So if the power is 5, right, like the one we had in this example, right, we had, this is the example we looked at with the Pascal's triangle. The power is 5. So the binomial coefficient for this one would start with 5 choose 0. By the way, this is how we read this notation. N choose r. That's not divided. These two are not being divided. That's that formula. Okay, n factorial over r factorial times n minus r factorial. So we're not dividing n by r. We're doing that. N factorial divided by all of that. Okay? All right. So for the first term in here, for the first term, how would we get that? Well, that's 5 choose 0. Why choose 0? Remember the Pascal's triangle? The coefficient for the first one begins with this to 0 power. So we start by 5 choose 0. So this will be, instead of n choose r, instead of that, n would be 5. Well, let me use my scratch paper. And I'm going to rewrite this so you know exactly what I'm talking about. So I'm going to rewrite this same example we solved using the Pascal's triangle, the same one. This time, though, instead of calculating the coefficients using the Pascal's triangle, we're going to use the binomial theorem. So let me write it so we have it on the scratch paper here. So this is A. I can move this up a little bit. A plus b to the 5th power is equal to a to the 5th plus, oops, it's slipping. Like that. So a to the 5th plus a to the 4th b plus a to the a cubed b squared plus a squared b cubed plus a b to the 4th plus b to the 5th. Okay, that was the expansion of this. But as you know, we need these coefficients. We saw how we can get those coefficients using the Pascal's triangle, right? But how do we get it using this formula? Well, for that one, we're going to use this formula. It's 5, n is 5. 5, choose 0 for the first one. How about that one? What is that coefficient? That's going to be 5, choose 1, right? That one, 5, choose 2. That one, 5, choose 3. That one, 5, choose 4. And that one, 5, choose 5. So when we do this, either using the formula or using the calculator, it's going to give us those same coefficients. So 5 choose 0 equals 1, and 5 choose 5 is also equal to 1. Okay? That's what you get from this formula. 5 choose 0 it's going to be equal to 1. 5 choose 5, you're going to get 1. What about 5 choose 1? That's 5. Okay, let's calculate these. Because I don't know from memory, I can't calculate that. So let's do that. Okay. Well, let me write down the coefficients we got from the Pascal's triangle. Okay. Here are Pascal's triangle numbers. We got 1, we got 5. So far so good, right? They match. The binomial calculation and the Pascal's triangle coefficients match. And then the other ones are 10, 10 again, 5, and then 1, which is of course the same. Okay, so now let's verify using our calculator. We already know, well, we can calculate those two. It doesn't matter. So let's do that. Where do I put my calculator so you can see everything, the screen? Okay, I think that's good enough. Okay, so let's calculate 5 choose 0 to see if we get 1. So 5, PRB in my calculator, NCR is N choose R. The same thing, you see NR. Do you see it? You can barely see it. N choose R, that's the same thing. That's the middle one. NCR, N choose R. That capital C stands for choose or combination. N combination R. N choose R. Okay? So I'm going to pick that. It shows me that I picked it. 5 NCR. Then I'm going to put in 0. Okay? 0. Enter 1, which is what we have. Let's calculate 5 choose 1. Right? So 5, once again, 5 choose 1. We should get 5. There it is. 5. Now we want to calculate 5 choose 2. We need to get 10. Are we going to get 10? 5 choose 2 and 5 choose 3. For both of those, we need to get 10. Let's see if we do get 10 for those two. So 5 choose 2, 10. Now let's calculate 5 choose 3. 5 choose 3, 10. So we got these two. So what do we get from 5 choose 4? Do we get 5? Let's see if we get that. We need to get 5 choose 4 should give us 5. Let's see if we get that. 5 choose 4. 5. Okay, there we have it. 5 choose 5. Let's see if we're going to get the one that I wrote down. Okay, 5. Oops, sorry. 5 choose 5. 1. We have it, right? So we were able to get, using the binomial theorem, 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. We were able to calculate all those question marks, which are the coefficients of the binomial expansion. Okay? So that's how this formula works. You can plug it in. I mean, it's just manual calculation wise, you can plug those numbers in here and you get the same thing that the calculator does. Okay, and what you see here is what I've explained when we were talking about incrementing this R from 0 and then 1 and then 2 and 3 and so on. Okay, and this R equals N equals R in here was the last term, right? 5 choose 5. 5 choose 5. So N, that's N That was r. So the last term is always n equals r. 5, choose 5. That's what that is saying. That's what that is saying. Okay? Okay, so here, they just want us to calculate 8, choose 3. Let's do it manually and both with the calculator and manually, right? So given our formula, we know that the formula is like this. N choose r is equal to n factorial divided by r factorial times n minus r factorial. That's the formula we had on the other page, right? I just wrote it so it's in front of us as we calculate this. 8 choose 3. So let me write this down. This is read or pronounced as 8 choose 3. That's how we read that mathematical notation or symbol. All right, so let's plug in. We have 8 choose 3 equals n factorial, n is 8, divided by r factorial, so 3 factorial, times 8, n minus r factorial, 8 minus 3 factorial. What is that equal to? That is equal to 8 factorial over 3 factorial times 5 factorial. Okay, so let's calculate that. This is manually calculating it, right? We're going to do this, and then we're going to use the calculator function that I showed you, and you'll see how much easier it is with the calculator. So 8 factorial, let me put that here. I think it looks like that. Okay. So first, let's calculate 8 factorial. 8, PRB button. I'm going to scroll over to the exclamation mark, which is the factorial notation. 8 factorial, enter, it's that number in the numerator. So 40,320 divided by 3 factorial is easy, right? 3 factorial is 6, right here. We already have it. 3 factorial is 6, or 3 times 2 times 1, right? 6. 5 factorial, it's 120. It's on that sheet again, right there. It's 120. 5 factorial is 120. But let's calculate it using our calculator. 5, PRB, scroll over to the exclamation mark. Notice I'm skipping the function that I just used a few minutes ago, right? Because I want to show you how you do this manually, as well as how you do it using the proper button here. Okay, so let's grab that. 5 factorial is 120. Right? So what is this equal to? We have like that. So this is 720. So we have 40,320 divided by 720. So let's do that. So we have 40,320 divided by 720. 56, right? We got that. So 8 choose 3. Oops, let me bring this over. So 8 choose 3 is equal to 56. So let's see if we get that result from our calculator. So we have 8, right? Like that. And then PRB, then let's use the appropriate function. 8 choose 3. 56. Okay? Wasn't that easy? It's pretty easy, right? Okay. Now, let's use the binomial theorem, not Pascal's triangle, right? Let's use the binomial theorem to expand this expression. So let me ask you this. Without having seen the expansion, how many terms are we going to have? Are we going to have 8, 3, 6? How many terms? If you said 5, you are correct, because n plus 1 or 4 plus 1 is going to be 5. So we are going to have 4 plus 1 or 5 terms in the binomial expansion. Okay, so now that we know that, let's go about expanding this. So we know that the first term is going to be first term to that full power, right? Square root of 4, oh, sorry, not square root of x to fourth power. What about the coefficient? Using the binomial theorem, it's going to be 4 choose 0, right? So, plus the coefficient of the second term, we know it's going to be 4 choose 1. Now the terms are going to be square root of x, reduce the power by 1, so 4 becomes 3, and then bring in that term, times negative 5y to power 1, right? 1 plus 3 is 4, or equal to that power. Okay? I'm going to have to write these smaller so I can fit them in across the page. I may not be able to, though. It's too late, I guess, but we'll see. So 4 choose 2 is the binomial coefficient for the third term, right? 4 choose 0, 4 choose 1, 4 choose 2, times square root of x to what power? Reduce the power for square root of x by 1, so squared. Increase this one by 2. So, by 1. Sorry, by 1. So, by 1 to 2. Like that. Okay? Plus, the binomial coefficient will be 4 choose 3 times square root of x to reduce this by 1. So, it'll be power 1. Increase this power by 1. So negative 5y cubed. Okay, unfortunately I don't have enough space, so it's okay. I'm going to go here. I'm going to go below that, so like that. Plus, what's going to be the next binomial coefficient? 4 choose 4. Yeah, the last one is always going to be n and r are going to be equal. Okay, times, this is going to go away, this is going to be to power 0. If you reduce this power by another 1, you get square root of x to 0 power, which is going to be 1. Anything to 0 power is equal to 1, so it's going to drop out. And increase this power by 1, so times minus 5y to fourth power. Okay, now we got to clean it up, right? It's not simplified yet. So let's do that. So we're going to have 4 choose 0 is 1. 10 choose 0 is 1. 30 choose 0 is 1. Anything, any number choose 0 is always 1. And if you can find it out using this formula as well. Okay? So that is 1. It drops out. Square root of x to fourth power, it's going to be x squared. Right? I mean, let me explain it here. To simplify this, square root of x to the fourth power is equal to square root of x to the fourth power. Right? Then, we can rewrite this inside as square root of x squared squared power. Right? X squared squared. 2 times 2 is 4. The outside power always multiplies itself by the inside power. Okay? But this 2 and this index, which is missing, which means it's 2, are equal. So this term that is being squared can leave the radical. There, x squared. Okay? So this whole thing, 1 times x squared. X squared. 4 choose 1 is 4. We can calculate it very quickly, right? That coefficient, 4 choose 1. So 4 choose 1. 4, right? So we have 4, positive 4 coming from here. We have a negative 5 here that is being multiplied by it. So minus 5 times 4 is minus 20, right? Minus 20 square root of x cubed, or square root of x cubed. We can a little bit simplify it, times y. The y is outside of the radical, right? Right there. We can simplify this a little more. I will do that in the next step. I didn't want to combine both steps in one. I think that way it'll be more clear as you go through this. Okay, 4 choose 2. Let's find out what that is. So we got to be careful because we have a 4 choose 2 here, and then we have a minus 5 squared here, which is positive 25. Right? Let me bring this down. So minus 5 squared is 25. 4 choose 2. Let's find out what is 4 choose 2. 4 choose 2. 6. Okay? You can also use the formula that we talked about to calculate it. So we have 6 coming from here. This is 6, this quantity, times minus 5 squared, which is positive 25. Positive 25 times 6. Right? It should be 150. Let's just be sure. So 6 times positive 25, 150. So we have positive 150 square root of x squared. What is that equal to? Just x. Right? Square root of x squared is just x. And then, of course, y squared. So that's that term after simplifying. Then we have 4 choose 3. Let's calculate what this quantity is. 4 choose 3. Okay? So we have 4 choose 3. 4. But we got to be careful because 4 choose 3 is 4. I've already calculated that. But then we have a minus 5 cubed here, right? Minus 5 cubed is minus 125. Minus 125 times 4, it should be 500, is it? Minus 125 times 4, minus 500. So we're going to have the product of this 4 with minus 125 is minus 500. Square root of x to first power is just square root of x. Y cubed is y cubed. Okay? I hope this is making sense. Plus 4 choose 4. 4 choose 4 is 1, right? 10 choose 10, 1. 100 choose 100, 1. 80 choose 80, 1. Let's see it. We have 4 choose 4, 1. Okay? Anything choose itself is always 1. In how many ways you can choose? You can choose 7 out of 7, one way. Okay? So 4 choose 4 is 1. Minus 5 to fourth power. I got to be careful here because this 4 will make this positive. So 5 to fourth power, is it 625? Let's see. These are easy numbers, but I still would rather check to make sure. 5 to fourth power, 625. Okay, plus 625 y to the 4th power. Okay. Can we simplify this a little more? Not this, not this, not this, but this we can, right? So let's simplify it. So we have x squared. This square root of x cubed, we're going to simplify it. Let's see how. So, square root of x cubed, you can rewrite it as square root of x squared times x, right? That's the powers add up, you get x cubed again. So I split it so you can see, because this is square root and you have a squared term, this can leave the radical. In the process, it will lose its power. So we get x times square root of x. That x outside is that one that left the radical expression. In the process, lost its power because it's equal to the index of this square root. And we couldn't do this if this was plus or minus. If this was x squared plus x or x squared minus x, we couldn't do this. We can only do this when we have division and multiplication. Okay? So we have minus 20x square root of x y. And that's x square root of x times the square root of x is that, right? We simplified it. And the rest we can just write down. Like that. Okay? Having this method, the binomial expansion and the Pascal's triangle, having these methods are extremely useful, because without these methods, a binomial like that, to expand this, you would have to multiply this binomial by itself 4 times, right? Very laborious task. But with this method, you practice with these, a few of these, you'll get so comfortable with it, you can finish one of these in a couple of minutes. And imagine that, rather than sitting here and multiplying these binomials 4 times, or for higher powers 5 or 6 times by each other. It would be a very laborious task to do that. So these make the job much, much easier. Okay. So let's go to the next page. All right. So here we have another type of problem. It says factor the following expressions using the binomial theorem. When you factor expressions using the binomial theorem, when you do that, to do this, always note the first term the last term, which is that one, and how many terms you have. For these problems, A, B, and C, we're going to do that. These are the most important things. The first term, the last term, and how many terms do we have. The how many terms we have, it's going to tell us what the power on the outside should be. All right? You could pick that up from here, from the last term too, but sometimes it's not that easy. So there are multiple ways of factoring this. Okay, so we have 1, 2, 3, 4, 5. So with the power of the binomial must have been 4, right? Because 4 plus 1 is how many terms we have. 5 terms, so the power must have been 4. There, right? So notice the first term. The first term is x to 32 power. So whatever we had here, when it was, whatever power was here, when it was raised to 4th power, you got 32. So what power should this have been? 8. Okay, x to the 8 power raised to 4th power, we get x to the 32. Okay, then all of these are positive, so plus, we should have y here. The last term is just y to the 4th, so that's it. So we're done. That's the factorization of that whole expression. Okay, just having worked with expansion of binomials, we can easily factor it. Did you see how easy that was? You simply note how many terms you have. You drop that number by 1, and that becomes the power, because the expansion is 1 more than the power, right? So you know the power is 1 less than how many terms you have. You have 5 terms, then the power should be 4. Then you figure out, using the first and the last term, you figure out what should be on the inside. So you might want to complete these two on your own, stop the video or pause it, and then come back to it once you're done with your solutions. Okay, please do that for parts B and C, because number 5, it's going to be different. It's a different kind of a problem. Okay, so I'm assuming you've done that, and now you're back. Okay, great. So let's look at we have 1, 2, 3, 4, 5. So this power must be 4 on the outside, right? So the first term is 16t to the 4th. So we know we must have had a t here. So t to the 4th is t to the 4th. And then what number raised to 4th power gives us 16? 2. So that's the first term, 2t to the 4th power. Everything here is positive, so I'm going to put a positive there. Okay? If I had alternating algebraic sign like plus, minus, plus, minus, plus, then I would put a minus there. Okay? Now, look at the last term. That's an interesting one, because the negative power indicates a fractional expression, right? So let me use my scratch paper here, if you don't mind. So 81t to the negative 4. So I'm using this as a scratch paper. Sorry if it's missing. But we have that, right? So you can rewrite this as 81 divided by t to the 4th, positive 4, right? Because this same thing you could have written as 81 times 1 over t to the 4 using positive 4 power. That is the same thing as that. Or 81 divided by t to the 4th power. So we know whatever we have here must have had a t in the denominator, because that's negative 1 when you bring it up. Not now, but when you bring it up, it becomes t to the negative 1 power times 4 on the outside. It's going to give us t to the negative 4 power. What about the 81? What number raised to 4th power is going to give us 81? I mean, it's 3, but even if you don't know that, you can take the 4th root of 81 to find out. So to take the 4th root of 81, you simply say 81 2 raised to 1 over 4 power, and it's 3. Okay? If you know it, you can just write it. If not, you can find it like that. So this expression is 3 over t. The second term is going to be 3 over t. Noticing that negative 4 is a clue to us that we must have t in a fraction form like that, in the denominator of a fraction. And all the coefficients that you see then will be calculated using the binomial and all of that. Okay? But that's that. This one, once again, how many terms do we have? 1, 2, 3, 4, 5, 6. Oh, we have 6 terms. So we must have a binomial with the power on the outside equaling to 5, because we know the number of terms should be that power plus 1. Okay? So the first term is 32x to the 5. So we know we have to have an x here. X to the 5th power is that. What about 32? What number raised to 5th power is going to be 32? Well, if you know, it's 2. If you don't know it, you take the 5th root of 32. To take the 5th root of 32 in my calculator, you have to raise it to 1 over 5 power. So 32 raised to 1 over 5. Right? 2. If you don't know what's going on here, let me explain. And I'll use this scratch paper again. Right? You want to find out 5th root of 32, right? Well, you can rewrite this with rational exponent, right? 32 can be written as, what is the power on the inside? The power on the inside is 1. So you can rewrite this radical expression as a rational exponent, as a term, as a number with a rational exponent, 32 to 1 over 5 power. So that's why in my calculator you saw me do 32 caret, which means raised to power 1 over 5. That's how I was able to get the 2, okay, which appeared here. Now take a look at the 243. Now I don't know what number raised to 5th power is 243, right? First, and the other thing is that everything here is plus, so plus. If it was plus, negative, plus, negative, then I would put a minus here. But it's all plus, so plus. Then we're looking for a number here such that if you raise it to 5th power, you get 243, right? What is that number? Well, I don't know. Let's figure it out. We have to do that, we need to take the 5th root of 243. So let's take to take the 5th root of 243 caret parenthesis 1 divided by 5. What do we get? We get 3. So 3 to the 5th power is 243. So all we need here is a 3, and we're done. We're done with that, and we're done with that. Okay? If you still have questions about why we're raising 243 to 1/5 power, let me explain. So we want a number here. If we didn't know 3, we would be looking for a number that when raised to 5th power, it's going to be equal to 243, right? So what number, let's call it x, what number for 5th power is going to give us 243? Well, take the 5th root of both sides. Right? Now on the left, things are easy. X, right? This and that cancel each other out because it's the 5th root of x to the 5th is this, x to the 5 over 5 power. This 5 divided by that 5. But that's x to power 1, which is that. Okay? What about the right side? The right side is just going to be whatever this is, because it's not going to be, if this was the sixth root, we would have plus or minus. But because it's an odd root, we're just going to get whatever that number was. If it's negative, it's going to be negative. If it's positive, it's going to be positive. So itself. So we have, on the right, we have 243 to what power? The power on the inside here is 1. The index of this root, or the root, is 5. So to write this radical expression in terms of a rational power, it would be 1 divided by 5. And that's why in the calculator you see me enter this, 243 caret 1 divided by 5, which gave us 3. Okay, that's why. That caret means raised to power that. To raise this number to that power. I hope that cleared that up if you have questions on it. Okay, now this last problem, it's a little bit different. It says find the term containing b to 28th power in the expression that. It says there is a term. Well, first of all, how many terms are we going to have? Total. We're going to have 17 terms, right? So we have 16 plus 1, 17 total terms in this binomial expansion. Right? We know that. One of those terms contains b to the 28th power. We're looking for that full term. That term is not just b to the 28th power. It has other things associated with it. We're looking for the full term, and this is part of it. Okay? So let's look at this b, the binomial itself. If we're going to raise b to the 4th to some power and get 28, to what power should we raise it? We're going to have to raise it to 7th power, right? So b to the 4th power raised to the 7th power is going to give us b to 28th power, right? Okay. Now that we know that, and we already know how to expand the binomial, right? We know that if the power of that term is 7, what should be the power of, by the way, that should be minus b to the 4th, minus b to the 4th to 7th power, right? So let me add that in, because it's minus there. So this is minus b to the 4th to 7th power. Okay? So, what should be, we know how to expand binomials, so we know then, so thus, that square root of 3 should have what power? If we're multiplying by minus b to the 4th to 7 power, what should be the power of this? Do you remember how we determined that? The summation of these two powers should be equal to the power on the outside. So what should this power be? That power should be, of course, 9. 7 plus 9 equals 16. Right? Are we done? We're not done. Right? What are we forgetting here? Or what is it that is missing? We're not forgetting about it, but what is it that is missing? The coefficient. The coefficient here is missing. The coefficient would be 16. Choose something. Right? We need to determine what term this is. we need to determine what term this is because we always increment this from 0. Remember that? Let me bring one of these examples. Remember these coefficients using the binomial theorem always get incremented from 0. So if the power is 4, we start with 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4, and so on. So for this term that contains b to the 28th power, which term that is, it's important because that'll tell us what that number should be. Okay? If we're starting from 0 and we ended up, and for 0 this would be 16, right? And there would be no b term in the first term. In the first term, this would be 0, and this would have this term, that term would have power 16. And every subsequent term would have that power reduced to 15, 14, 13, 12, and so on. So then how many terms we have to go before we go from 16 to 9 for the first term? Right? We start from 0. We start from this. I can write it on the scratch paper. We can do a quick investigation of that, and we'll be done with it very quickly, right? So we start with 16, choose 0, right? That's the first term. But that would be for square root of 3 to 16th power. We don't want that. We want the one where square root of 3 is to 9th power, right? So we go to 16, choose 1, square root of 3 to 15th power. 16, choose 2, square root of 3 to 14th power. Right? Let me move this up. (16) choose 2, square root of 3 to 13th power. 16 choose 1. 1, 2, 3. Sorry about that. 3 and 4. Square root of 3 to 12th power. 16. So far, so good. We're going to go to 9, right? And then I'm running out of room here. Let me come back this way. 16 choose 5 times square root of 3 to 11th power. 16 choose 6 times square root of 3 to 10th power. Right? And 16 choose 7. 16 choose 7 times square root of 3 to 9th power. So 1, 2, 3, 4, 5, 6, 7, 8th term. Right? So it is 16. Let me just make sure. 16 choose 7. So that's the one we're looking for. Right? This is the coefficient we've been looking for because that's the coefficient when we have square root of 3 to 9th power. There is an easier way for this, but I just wanted to show you this crude way without the formula, but there's a formula for doing this, for finding any term of a binomial expression. We will get to that. So this question mark then is 7. Okay, we just listed each one to get to that, and it's 16 choose 7. So we have 16 choose 7, square root of 3 to 9th power, minus b to the 4th to 7th power, right? So what is 16? That's going to be an irrational number, so I'm going to leave that alone I'm going to leave that as square root of 3 to 9th power. I'm not going to calculate that because it's going to be some decimal number. Square root of 3 is irrational, right? But I'm going to calculate this, and I'm going to write it down. 16 choose 7. Okay, let's calculate that number. 16 choose 7. It's that, 11,440. So we have 11,440, which is that, times square root of 3 to 9th power. This minus comes in front, right? Because this minus is being raised to 7th power, not 28th power. This minus is being raised to the 7th power. So that minus is going to be preserved, and it's going to come here, minus 11,440, square root of 3 to 9th power, which I keep because I'm avoiding the decimal value, and then times b to 28th power. So this is the term, this is the full term that we were looking for among the 17 terms that we have, right? Okay, so another way of finding this, maybe I can fit it in here at the bottom using the formula. I think the formula, so n choose r. I wrote it someplace. So x to n minus r times y to r. Okay, so the general term the formula for the general term of a binomial expansion is general term, right? So it's this one. It's n choose r times x to n minus r power times y to r power. So that's the general term you can use to find that. So here we knew in our case, in this case, let me write that. So in the above case, we figured that n was 16, right? And r was 7, and that's all we need, right? And x and y, of course, were, let me write that. X was square root of 3, and y, in our case, was minus b to the 4th. Okay, so we have that, we can plug it in here, and it gives us that term. The most significant piece of this was that, to figure out which term, it was the 8th term, right? It was the 8th term, but because we're starting from 0, we start with 16 choose 0 for the 8th term, we reach 16 choose 7. Okay? So this wraps up this discussion of the binomial theorem of section 12.6. And with this, we have wrapped up this course. I hope you found these instructions helpful. And if you have questions, please make sure you bring them to me. And have a nice day. And I hope you'll do extremely well on the final exam.